So hi, I'm Joyee, and today I'm going to talk about Node.js at Alibaba. So my name is Joyee Cheung, or it's Joyee Cheung in Mandarin Chinese. I work on Node.js infrastructure at Alibaba Cloud. I am a member of the Node.js technical steering committee. You can find me on Twitter or GitHub via the handle Joyee Cheung. Okay, so here is a brief history of Node.js at Alibaba. In 2011, we launched the first Node.js application in production. This is an application for Taobao.com. After that, Node.js applications start to grow in Alibaba, and the need for a faster internal NPM registry rised. So in 2014, CNPN was developed. It was open sourced and has been speeding up Node.js installations in mainland China ever since. There is also a internal NPM registry based on CNPN for internal packages, which I'm going to talk about later. During this time, we got more and more Node.js applications developed in Alibaba, some of them serving heavy traffics, and we started to bump into performance problems. So in 2015, we launched the Node.js performance platform, previously known as Alinode. It's for monitoring and profiling and optimizing Node.js applications in production. In the meantime, there were various Node.js web frameworks developed in different subsidiaries of Alibaba. So in 2016, in an effort to unify the development practices across the Alibaba ecosystem, we developed Act.js and migrated most of the internal frameworks on top of that. And after Act.js has proven itself in production, we open source it on GitHub. So this is where we are now. In Alibaba, most Node.js applications are now what we call the backend for front-end applications. They usually talk to existing distributed systems. In other languages, they do a little bit routing and data processing, and then render web pages or send JSONs to clients like in browsers or mobile phones. So some of them are new applications. Some of them are just refactoring out like legacy PHP or Java web applications. At the moment, we have over 1,000 applications running on tens of thousands of machines in Alibaba. Okay. So after years of development, we have built a pretty mature tech stack for Node.js. This includes web frameworks, an NPM registry, infrastructure integration, a set of deployment practices, and a Node.js performance platform for monitoring and profiling applications. I'm going to talk about how we make Node.js work in a big enterprise like Alibaba and what we have learned during this journey. So before we start, we need to, so when we talk about Alibaba, we are not usually just talking about the Alibaba Group that has been publicly traded, but we are also talking about other companies in the whole Alibaba ecosystem, including like affiliated entities and companies like acquired by Alibaba, because most of them share the engineering practice with other subsidiaries, and this directly influences how the Node.js tech stack is structured. For example, like some acquired companies come with their own legacy infrastructures and conventions. But when building Node.js applications, we still want to share code that has nothing to do with these differences. If we build a framework like with too many conventions built in, then when we got new teams joining Alibaba by acquisition, then these conventions could get in their way of adapting our framework. But if we leave too much room for configuration, then we could end up with a lot of boilerplate code that hurts productivity. So Act.js is our solution to this problem. We first built a core framework on top of Koa. Koa has been very popular in Alibaba because people like to write asynchronous code in synchronous fashion. And it also makes the migration to async await almost effortless. So this core framework is basically just responsible of loading plugins. On top of the Act core, there is Act.js, which comes with plugins that serves common needs of an enterprise Node.js application, like cluster management, internationalization, securities, and stuff. Then on top of the open source Act.js, we add more internal plugins that deal with services and conventions for the whole Alibaba ecosystem. Then each subsidiaries can customize their own framework by adding more plugins that handles services and conventions of their own. So by layering the work of framework builders, application developers can still enjoy the productivity brought by conventions while avoiding the overhead of configurations. And there was another problem during the adoption of Node.js in Alibaba, or rather, the adoption of Node.js in China. So due to various reasons, access to overseas storage like Amazon S3 or overseas CDMs from mainland China is usually either slow or just completely blocked. So one of the most important thing that a Chinese developer, where I learned, is if you're going to use a packaging manager of some sorts, go find yourself a mirror in China first. The npm.js.org registry is still accessible in China for most internet service providers, and we are able to publish packages there, but for installations, it's not fast enough. So at the moment, the most popular npm mirror in China is registry.npm.taobao.org. Taobao is a subsidiary of Alibaba, and the mirror is funded by Alibaba Cloud. This whole solution is open sourced on GitHub under the CNPN organization. So the mirror currently serves like millions of downloads each day in mainland China. In order to make it work, we first synchronize packages from the npm.js org registry to an overseas server that is outside what we call the Great Firewall, but still accessible, reasonably accessible in mainland China. After that, we synchronize packages to registry.npm.taobao.org. Then this mirror distributes the packages via the Alibaba Cloud CDN to make the installation within mainland China as fast as possible. In addition to npm packages, this mirror also offers Node.js binaries and Electron distributions and other resources that a Node.js developer usually need to download. Inside Alibaba, we have an internal registry based on the public CNPN registry. It synchronizes public packages from the Taobao mirror, and it also hosts like internal packages. For example, our internal frameworks mentioned before. So far we have covered development and packaging management. Now let's talk about deployment. When the code is ready, it will be sent into our deployment pipeline. The build machine uses our internal npm CLI to pull down dependencies like packages and Node.js binaries, and then bundle them together. We would usually specify the version of or the release line of Node.js that an application depends on in package.json. The CLI will read this specification, download the corresponding Node.js binary, and put it under node underscore modules. So this binary, instead of the one in the global path, will be used to start up the application in production. Also, we share a set of similar practices for operating and managing Node.js processes, and these practices are baked into our internal frameworks via scripts and Docker files. So most application developers don't need to worry about them. And this bundle will be deployed to either a legacy container or a Docker container. Since we do need to support like older versions of Linux that the upstream does not support anymore, we have a custom Node.js runtime maintained internally. For example, the Node.js 8 release don't load on CentOS 5 anymore, since they have been built on CentOS 6 after CentOS 5 and its support. But we still need to support our version of Enterprise Linux 5 until most teams finish upgrading their operating system. So we need to build our own Node.js binary in order to make it work with older version of glibc. So after the applications are tested and deployed in production, some of them serving heavy traffic could get into performance problems from time to time. The existing monitoring platform that we had was language agnostic, and it didn't provide much insights for optimizing Node.js applications. So we have built a performance platform dedicated to Node.js applications. We modified the runtime to report internal statistics to our platform, and we allow it to take profiling commands in production in a controlled manner. The agent that talks to the platform is usually built into our web frameworks as a plugin. When developers deploy the application to production or when they start doing load testing, the performance platform will receive statistics from the agent and send out alerts when these data match expressions that they have set by the developers. Then the developers can use the platform to dispatch profiling commands, transfer profiles to the platform, and use the tools provided by the platform to do optimization. And the runtime is modified so it can record profiling command, it can record profiles in a specified amount of time on demand. So after the profile is generated, the application will continue to run without the overhead brought by profiling. And it can take another profiling command later if the developer wants to. This is especially useful when dealing with performance problems of applications handling heavy traffic because usually it would be very hard to reproduce the issue when the application is offline. Okay. So here are some profiles that we usually use to help optimize these applications. The Chrome DevTools is definitely one of the most powerful tools that can be used to analyze CPU profiles and heap snapshots. And the DevTools can be easily integrated into a replication. We have also built custom visualizations to analyze the garbage collection logs. And we also have extended the memory analysis tool of Eclipse to analyze VA heap snapshots. This can find suspicious objects that could cause memory leaks, like automatically. Sometimes core dumps can also be used to help identify memory problems. And one of the best tools to analyze Node.js core dumps at the moment is Alinode. So far, Node.js has been working great in Alibaba, I would say. But what's next? Well, serverless is like all the rage these days, and Alibaba Cloud has just released our serverless product called Function Compute. Well, serverless is not a silver bullet, of course, but for certain types of applications, they are an ideal solution in terms of productivity and maintainability. And there are already teams in Alibaba talking about using our serverless product to build lightweight applications instead of using our existing infrastructures, which is more complicated in comparison. And we have started the integration with the serverless framework to make the developer experience better. So we are excited to see how it's going to change our development practices in years to come. Okay, that's all. Thanks for listening.